4 facts. First, in the year 1816, one of the largest migrations in the history of America began. Hundreds of thousands of families left everything they had behind and started moving west. Second, the bicycle was invented because in Germany there simply wasn't enough food left to feed the horses. Third, the deadliest cholera epidemic in human history, the one that killed millions of people all around the world, also began in the year 1816. Fourth, at that same time, several scientists, for the very first time in history, began to systematically measure the weather and look for patterns, and from this, meteorology as a science was born. All 4 of these facts are connected. They all have a single source. On April 10th in the year 1815, a massive volcano erupted in Indonesia, and the year that followed became the year without a summer. Hi, glad to see you again, or if this is your first time here, really glad you stopped by. Today's story is about the year 1816. It was called many different things. The year without a summer, the year of poverty, even 1800 and froze to death. That was literally a nickname people used back then. It was a year when the average annual temperature in the northern hemisphere dropped by almost a full degree. And it doesn't sound that scary, right? But that exact change led to the largest agricultural crisis in the Western world in all recorded history. And the most surprising part is that no one at the time understood what was happening. People saw the cold, they saw their crops fail, they noticed that the sun looked strange somehow. But the real cause was only discovered about 100 years after it all happened. Today we're going to go through the whole story from the volcanic eruption to the consequences that are still felt even today. And let's get into it. To understand 1816, we need to go back to April of the year 1815, to the island of Sumbawa in Indonesia. There stood Mount Tambora, around 4 kilometers high. Not the largest by Indonesian standards, but still a very noticeable and imposing volcano. It hadn't erupted for roughly 5,000 years. And over time, the people living on the island had simply gotten used to it, thinking of it as nothing more than just another mountain. On April the 5th, 1815, the volcano began to rumble. At first, it sounded distant and strange, but over the next few weeks, something happened that South Asia had never seen in all of recorded history. The explosion was so powerful that it was heard more than 1,000 kilometers away and was often mistaken for cannon fire. On the Volcanic Explosivity Index, Tambora was rated a level 7, which is the second highest level, almost the maximum possible category. What does an eruption of that magnitude actually mean in practice? Ash covered everything within a radius of hundreds of kilometers. The layer was thick enough to collapse the roof of houses under its weight. According to surviving reports, up to a meter of ash was floating on the surface of the ocean, and ships literally had to push their way through that dense mass. On the island of Sumbawa and the neighboring island of Lombok, around 90,000 people died, most of them not from the eruption itself, but from famine and disease in the months that followed. It remains the deadliest volcanic eruption in human history. But the most important part didn't happen on the island. The most important part happened high up in the stratosphere. Lighter particles and huge amounts of sulfur dioxide were carried high up into the upper layers of the atmosphere, forming a massive aerosol cloud. This cloud slowly spread across the entire planet and began reflecting sunlight back into space, blocking part of the sun's rays from reaching the surface. In effect, the Earth got something like a giant invisible sunshade, but unlike a normal shade, this one stretched across the entire northern hemisphere, covering countless countries at once. And there was no way to take it down or remove it. The impact didn't show up immediately. The eruption happened in April of 1815, but the real consequences didn't begin until the summer of 1816. Why the delay of more than a year? Because it took time for the aerosols to move through the stratosphere, spread evenly around the hemisphere, and build up enough concentration to actually affect the climate on a large scale. So, the summer of 1816. Europe and North America were both facing unusual and extreme weather. In May, frost destroyed the majority of crops in New York, Massachusetts, and New Hampshire. Then in June, heavy snow fell in Albany, New York, and across parts of Maine. In New Jersey, farmers experienced 5 consecutive nights of frost, all in June. By July, lakes and rivers in Pennsylvania were still frozen, and in Virginia, the cold weather continued all the way to the end of August. Now imagine being a farmer in New England at that time. You plant your crops in the spring, expecting a normal season. In May, a frost hits and kills all the young seedlings. You replant, hoping for better luck. In June, snow falls and wipes out the new plants. You replant again, only for frost to return at night in July. The entire summer is cold, wet, and gray, with rain and clouds dominating every day, leaving almost no chance for a proper harvest. By some estimates, crop yields in New England fell by a staggering 90%. Not 10, not 30, but almost the entire harvest was lost, leaving farmers desperate and struggling to feed their families. Europe fared no better. Already weakened by the Napoleonic Wars, the continent faced the worst famine of the entire 19th century. In Britain and Ireland, cold temperatures and relentless heavy rains destroyed wheat, oats, and potatoes, leaving fields empty and communities in crisis. In Ireland, rain fell for 8 full weeks without stopping. Potatoes rotted right in the ground. Famine soon followed, and an outbreak of typhus spread through the weakened population, killing more than 40,000 people and creating one of the most severe humanitarian crises of the time. Food prices soared across Europe. Hungry people poured into the streets near bread markets and bakeries, desperate for anything to eat. Food riots erupted in many cities, and the unrest of 1816 and 17 became the most violent period in Europe since the French Revolution. And there was another, even more important factor: psychological. No one knew what was happening, and no one knew when it would end. Today we can open our phones and see a weather forecast for the next 2 weeks. Back then, people had no such information. They could only watch as summer failed to arrive, as the cold dragged on, and as the second round of crops was destroyed. They knew winter was coming, but there were no reserves to rely on. For everyone living at that time, it was complete darkness, both literally and figuratively. No one could predict how long the cold would continue. When crops froze yet again, people planted a third time, not because it would surely succeed, but because they had no other choice and no other way to survive. The sky that year looked very strange. The aerosol haze in the atmosphere was so thick that people could actually look directly at the sun with their naked eyes without being blinded. And what did they see? Dark spots appearing across the surface of the sun. Galileo had described sunspots more than 200 years earlier, but most people had never seen them. Normally the sun is far too bright to observe safely, but now, suddenly, the spots were visible to everyone. People looked up and thought, this is it. The sun is fading. These dark marks are stealing its heat and causing the cold. The London Chronicle reported that the unusually large sunspots sparked ridiculous fears and absurd predictions. People believed the spots were the cause of the bitter cold, and that their growth was a warning that nature itself was dying and that the end of the world might be near. The strange sky and visible sun became a powerful symbol of dread for many who lived through that summer. The end of the world. In 1816, this was not a metaphor. It was a literal expectation for many people. One prophecy claimed that the world would end on July 18, 1816. Across Europe, it caused a wave of panic. But look at how the human mind works under uncertainty. People did not just sit frozen in fear. They searched for explanations. Even if they were wrong, even if they were absurd, they needed answers. This is the same pattern we saw during the witch hunts of the Little Ice Age. When people couldn't understand why everything was going wrong, the mind created explanations from whatever was at hand. Volcanic ash in the atmosphere scattered sunlight in a unique way, creating incredible orange and red sunsets. The skies of those years were phenomenal in their beauty. An artist noticed it. The high concentration of volcanic ash produced unusually striking sunsets and strange skies, scenes that painters of the time captured in their works, turning natural disaster into stunning visual inspiration. Imagine a farmer's family somewhere in Vermont or Ohio. The year is 1816. For the third time that summer, they plant their crops. And for the third time, the harvest fails. They have a house, they have land, but there is nothing to feed the family with. Then rumors start spreading through the village. To the west, beyond the mountains, beyond the Ohio River, beyond the Mississippi, there's other land. People say it's more fertile. They say it is warmer. They say people there are starting over and actually succeeding. It was during 1816 and 17 that the flow of settlers moving west across North America grew sharply. The roads were crowded with wagons. People traveled from New England to Ohio, Indiana, and Illinois. Some went even farther, chasing a chance for a new life on new land. In Europe and the German lands, a self-taught inventor, Baron Karl von Drais, witnessed the effects of the climate shift with his own eyes. The problem was this: the price of oats, the main feed for horses, had skyrocketed due to poor harvests. Horses were the primary means of transportation at the time. Expensive oats meant expensive travel. Drais came up with the bicycle, or rather its predecessor, the Laufmaschine, a kind of adult scooter that moved without any help from animals. No horses, no problem. He patented the device a year later. The eruption of Mount Tambora and the disruption of the monsoon rains in India caused unusually late and heavy downpours. Many scientists believe these events affected the Bay of Bengal ecosystem and triggered a mutation in the cholera bacterium, creating a dangerous new strain. A year after the eruption, the first global cholera pandemic began in Bengal. Climate changes after Tambora may have helped set the stage for it. The new strain spread quickly with trade caravans, merchant ships, and armies, sparking a global pandemic that lasted until 1823 and killed millions. Cholera pandemics continued intermittently for nearly a century. Out of this crisis, modern epidemiology emerged. For the first time, doctors began systematically studying how disease spreads through water, laying the groundwork for understanding and controlling epidemics in the future. Moreover, that year raised a question that no one could answer. Why was it so cold? And that question haunted scientists for years. Before 1816, weather was seen largely as a force of nature, unpredictable, immeasurable, beyond human control. Meteorological observations existed here and there, but they were sporadic and lacked any unified system. After the year without a summer, everything began to change. In Europe and North America, the first networks of weather stations started to appear. Scientists began sharing data on temperature, pressure, and wind direction, trying to find patterns. The first attempts to link unusual climate to volcanic activity began. American scientist Benjamin Silliman from Yale publicly suggested in 1816 that strange weather might be connected to something happening in the upper layers of the atmosphere. The correct answer would take another 100 years, but the question had been asked. It was the year without a summer that sparked the scientific drive to understand whether weather could ever be predicted. Finding the answer to that question would take nearly 2 centuries. After the terrible summer of 1816, people feared one thing above all, and that fear stayed with them forever. Winter arrived harsh and unrelenting. In many regions of Europe and North America, food supplies were nearly exhausted. Grain prices remained sky high, and people still had no idea what had caused the climate to go so terribly wrong. The fear of another lost summer hung over every village and town. But slowly the weather began to improve. The summer of 1817 turned out to be much warmer. Crops started to recover, fields once again produced grain and other staples. Rivers and lakes that had been frozen in the previous summer were now flowing freely, and the threat of frost had finally lifted. The reason was simple, even if no one at the time understood it. Volcanic ash and aerosols cannot stay in the atmosphere forever. Over time, particles gradually settle or are washed out by rain, and sunlight slowly returns to normal levels, restoring the natural rhythms of the seasons. By 1818, the weather had largely returned to familiar patterns, and the world once again resembled the one people had known before the eruption. But the consequences of that year did not vanish. Families who had migrated west never returned to their old homes. New settlements grew and flourished along the Ohio, Indiana, and Illinois territories, reshaping the map of North America. The bicycle, invented as a response to a food crisis in Germany, continued its development and became a common form of transport within a few decades. Cholera, triggered by the climate disruptions and spreading from Bengal, continued to appear in waves across continents for nearly a century. And scientists never forgot the most important question posed by 1816. Could weather ever be understood? Could it be predicted? Sometimes a volcanic eruption lasts only a few days, but its effects can ripple across the world, changing societies, economies, and science itself for decades. 1816 proved that nature can strike suddenly, and that the consequences of a single event can be felt for generations. Historian John Post called this year the last great survival crisis in the Western world. The last because after it, advances in medicine, agriculture, and trade networks meant that such widespread death from famine in Europe and North America would never happen again on that scale. At the time, people had no understanding of the true cause of what they were experiencing. There was not a single person on the planet who could explain that the volcanic eruption in Indonesia a year earlier was behind the freezing cold and failed harvests. That connection would only be discovered at the beginning of the 20th century, once scientists had the tools and methods to analyze the global climate and trace the effects of volcanoes on weather patterns. Thank you for watching and for staying with me all the way to the end. I hope this story of 1816 gives a sense of how a single event can ripple across the world, shaping lives, science, and history for decades. See you next time.